Today we're going to talk about section 2.5, which is factoring higher degree polynomials. Remember, we talked about factoring with quadratics, which is a degree 2 polynomial. So higher degree polynomials means you're going to factor cubics and quartics and things that are a degree 6 or 10, those higher degree ones. The goal is to get it factored down all the way, and that'll involve some complex numbers. So we'll get into all that. Now, there's a few tools we need to be able to factor, and those are division tools. So I'm going to do one review problem just to make sure we remember. Let's get a whole nice big piece of paper here. Let's do a long division problem to make sure that we have got that and remember it. Remember, we take whatever we're dividing and we put it in the little house, and whatever we're dividing by and put it outside. We look at those first terms. What do I multiply times 3x to get 9x to the fourth? Well, 3 times 3 is 9, and x times x to the third is x to the fourth. So then I multiply, I get 9x to the fourth minus 12x cubed. Then I'm going to subtract that. So I subtract, which changes that sign. And those cancel, and I have 15x cubed minus 2x squared minus 32. It's often easiest to just bring everything down, but you don't really have to. Really all you need is whatever terms are affected. But I'm going to go ahead and bring everything down just for illustrative purposes. So then, what does 3x, what do I multiply to get 15x to the third? Well, 3 times 5, don't forget that sign, we need that plus in there, and x times x squared. So then I have 15x cubed minus 20x squared. And again, I'm going to subtract that, which makes these cancel. And I'm left with 18x squared minus 32. So 3x times what's going to give me 18x squared? Well, 3 times 6 and x times x. So that gives me 18x squared and then minus 24x. And now I'm going to subtract again. So that changes the signs on those. So these cancel. Well, what happens here? Well, we can't combine those because this is an x term and this is just a plain number. So we just leave them 24x minus 32. So then I say, well, what do I multiply? 3x times what is going to give me 24x? And that's going to be plus 8. So I'm going to have 24x and then minus 32. And in this case, when I subtract, they both cancel out, and that means I have no remainder. So my answer of 9x to the fourth plus 3x cubed minus 2x squared minus 32 divided by 3x minus 4, that equals 3x cubed plus 5x squared plus 6x plus 8. So this is the long division way to do that. Now, you can do the same exact problem with something called synthetic division. So this is long division. You can use something called synthetic division. Now, the way you set up synthetic division is you start by writing out all the coefficients in descending order. So we have our term we're dividing here, and the first coefficient is a 9. That's for the fourth degree term. And then there's for the cubed term, for the squared term. Now, look, there's no linear term, so you have to put a 0 there for the synthetic division. You cannot forget any term. you've got to have all of them. So this is a 4th degree polynomial, so I should have my 4th, 3rd, 2nd, 1st, and then 0 power terms. You write out all your coefficients there. Then you're going to make a little box over here, a little partial box. And what you're going to do is you're going to put what you're dividing by there, but you can only divide by linear terms. So if you try to divide by x squared, you can't use this. Okay, so since this one here is a linear term, we can do this, but we need to know what number to put here. Well, we've got a 3 in front of the x and a -4 as our plain number. So what am I going to put here? Here I lined up all my coefficients. This one you're not lining up your coefficient. What you do is you set your linear term equal to 0 and solve that, and that's the number that goes here. So when you solve this, you get x is 4/3. And that is the number that goes in this box here. So for synthetic division, first we set up all our coefficients. Make sure you have every single term in descending order. Then we put our box over here. The linear term we're dividing by, it has to be linear. We just solve that, set it equal to 0 and solve that, and that number goes here in this box. So synthetic division, this is a little shortcut division that somebody discovered, and it is helpful because it's faster than the long division, but you've got to know how to set it up properly. All right, now draw a line there. What you're going to do is you're going to take this first number and just bring it straight down. Then you're going to take this number and multiply it times the 9, and then we're going to put it right here. So 4/3 times 9, well, that's 3 times 4, right? So that's 12. Now you're going to add these two terms to get a new one, 15. Then you just keep going. We multiply here. 4/3 times 15 is 20. And then, so we put that up here. And then we add these two. And you get 18. And you just keep doing that. 4/3 times 18. Well, 4/3 times 18 is 24. Put it up here. Add these two. 24. Then you multiply this one. So 4/3 times 24 is 32. And then add these two. This is 0. When this is your remainder, if we had done this with long division, and then this is your answer. Because this started out with an x to the 4th, your answer starts down here with an x cubed. So our answer is 9x cubed plus 15x squared plus 18x plus 24. Now, you notice it is not the same thing, is it? But we can factor out a 3 here. We get 3x cubed plus 15, or excuse me, 5x squared plus 6x plus 8. And this is the same thing. With synthetic division, you will get, you might get a multiple of what you would have gotten from long division. The reason for that is because of this right here, because we had to put it into a fraction. Now, why does that matter? Well, really the main reason we use synthetic division is to see if we have a remainder and to factor things out. so it's not going to matter in the end. All right, so I want you guys to practice one. Let's say we have 6x cubed plus 31x squared minus 66x plus 75, and it's divided by x plus 7. Now I want you to use synthetic division and divide that out. So pause it and do that. All right, so if we set it up, we have our coefficients, the third degree, second, first, 0. Then if we set this equal to 0, we get negative 7. So we put a negative 7 over here. Bring the first number down, multiply, and add, multiply, and add, multiply, and add. So what does this mean? This means that this answer is 6x squared minus 11x plus 11, remainder negative 2. Or you can write the remainder as negative 2 over x plus 7. So one thing I want you to notice, though, is if this is our polynomial we're dividing here, we'll call this p of x. If you look at this, what's p of negative 7? Well, that's 6 times negative 7 cubed plus 31 times negative 7 squared minus 66 times negative 7 plus 75. If you calculate that all out, you get negative 2. Notice, that's our remainder. This actually happens every time. This is called the remainder theorem. And it says, for some number a that happens to be a real number, if we take our polynomial and evaluate it at that number, we're going to get the remainder when we take p of a divided by, or p of x, divided by x minus a. So here we divided this, our p of x divided by our x minus a. If a is negative 7, we have x minus negative 7. We're dividing here. So if you want to know, you just need to know what the remainder is, which actually you do sometimes. You need to know if it's 0 so that you know if that's a factor. You can actually use this remainder theorem. You can calculate what the remainder would be without actually dividing it out by just evaluating it at a. All right. So, for example, let's say we have p of x equals 4x to the 5th minus 2x to the 4th plus 6x cubed minus 14x squared plus 2x plus 1. And we want to know what p of 2 is. So now we have two ways to do that. You can either plug 2 in to all those x places and calculate it out, or you can use synthetic division. Put your 2 up in the little house and all your little coefficients here, and then use synthetic division and get your answer. So this one you can easily do by hand, whereas if we had to take this to the 5th power and then multiply by 4, you should be able to do it by hand, but you might want to use a calculator because the numbers will get a little bit bigger. But here's your two ways. So by the remainder theorem, when you divide, you get this value of the polynomial at this x, whatever you divided by. If we divided x minus a, so that's what this is with the synthetic division, then we get our remainder. All right, let's see here. Now, why do we need to know all this for factoring? Well, because of the factor theorem. If you have a value, some number that you plug into the polynomial, if that equals 0, then we're going to use this little symbol, means if and only if. Then x minus a is a factor of p of x. So if you know this is a factor, then you know that the polynomial evaluated there is equal to 0. And if you know the polynomial evaluated there is a 0, that means it's a factor. The if and only if means one leads to the other, whichever way you want to go. We know this with, we also call these zeros. And we know this with quadratics. For example, let's just do a simple quadratic one here. If we solve this equation, then we can factor this. And we know that these are the two factors of this polynomial. And we know that the zeros are x equals -4 and x equals 2. So since we know that we have, this is our a value here. This is one of them, and this is the other a value. So x minus this a value and x minus this a value, those are factors of this because it leads to zeros. So your zeros will help you find your factors. Now, why is that important? Well, quadratics, it doesn't seem like that big of a deal, but what if we have like this one? Okay, well, how many zeros is this going to have? Well, by definition, a polynomial has as many zeros as its degree. So this is going to have 4 zeros. We have to figure out what some of these are. Now, I'm going to go ahead and give you one of them. We'll talk about some ways to find those on the next section. Easier, but we're going to start with 2 as a 0 because I know it works. So, and I'll tell you how to find the ones that work tomorrow. We'll work on, or the next section. So we use synthetic division to check and see if it works because we know that it's a 0 if when we divide it, we have a remainder of 0. So the goal is to have a remainder of 0. So you want to make sure this ends up with a 0. So we do our synthetic division, bring the first one down, multiply, add, multiply, add, multiply, add, multiply, add, and yes, it's 0, so that means it works. So that means one of the factors of this is x minus 2. Now here, we've got x cubed plus 3x squared minus 6x minus 18. So what this means is if I take this polynomial, divide it by x minus 2, that's my answer. So I need to keep going though because I want all of my factors because the number of zeros is the degree and it's also the number of factors. So we've got here, we're just going to keep this in the same line because it's easier. I'm going to just give you the one we're going to start with because we'll talk about how to figure that out in the next section. So we're going to start with -3 and divide that. So we have, remember this time we're just working with this part right here. So we want our remainder to be 0, that's the goal. So we bring this one down, multiply, add, multiply, add, multiply, add, and equals 0. So we're good there. So what does this mean? Well, this means that x minus -3 is also a factor of this polynomial here because it's a factor of this one. Remember when we made factor trees years and years ago and we broke it down and we said because 4 was a factor of 12, that meant its factors were also factors of 12. So just like it works the same way with polynomials. What we did was we took this one and we broke it down into x minus 2 times this one we had here, x cubed plus 3x squared minus 6x minus 18. And now we are factoring this one down, so its factors are also factors. So we've got x squared minus 6 in this case. Now, that doesn't factor evenly without using square roots. So we can solve this. We know that that means x is plus or minus the square root of 6. So that means that our other factors are x minus the square root of 6 and x plus the square root of 6. So these are the 4 factors of this polynomial here. And what that means is to solve this equation, we set each one of these equal, and we have x is 2, so we have it equal to 0. X is 2, -3, and plus or minus the square root of 6. So when we solve this, solving for the zeros and finding the factors are all wrapped up in each other. So hopefully that kind of helps given those things. We're going to do a few more examples in class, and you need to make sure you read through this section. Hopefully at least some of this is review. If you're having trouble with it, make sure you come into class with questions so we can go ahead and get those answered and figure out what's going on, make sure we've got this all solid. So read section 2.5 and make sure you've got good notes and questions written for next class.